Hello everyone again. This is lecture 9 part 1 of wave optics. Maybe this will be the final lecture of wave optics. In this we will again go on with further discussions of polarization. After polarization I will summarize the complete lecture and that maybe will be the end of wave optics. So let us not waste any time. I am Sameer Lavankar. Let us begin our discussion. Okay, so a course outline for you. We started with the introduction in which we understood the concept of wave optics, why wave optics came into picture, what was the difference between wave optics and Descartes' theory of light, why was wave optics necessary to prove the laws of refraction, what was the point which was necessary to prove which was not able to be proved by the Descartes theory. Descartes theory was the particle theory of light. Then the second concept we understood the Huygens principle, in which we understood a concept of wavefront. A definition of wavefront was being explained, and finally Huygens principle explained us or helped us to find the wavefront at some time t is equal to tau if we know the wavefront at some time t is equal to 0. Then in the third point we understood the concepts of refraction and the reflection of plane waves using Huygens principle. So basically in third point we proved the refraction and the reflection laws using Huygens principle and wavefront. Then in the fourth concept we understood the coherent and the incoherent addition of waves. In this we understood the concept of intensity, when the intensity is maximum, when the intensity is minimum. Also we understood the concept of Doppler effect in this as a small part after the end of incoherent addition of waves. Lastly then we understood the concept of interference of light waves in Young's experiment. What is interference, what are these central bright fringes, what are these dark fringes, etc. We also understood the concept of Young's experiment. What is the Young's experiment, why was a phase locking necessary for the Young experiment to take place, why it was not being considered for a single slit, why only double slits are required, why was a source slit required, what were the effects on the screen when the, let us say we increase the wavelength, we change the capital D value, we change the small d value, etc. Also we understood the effects if a monochromatic source of light is being replaced by a white source of light. So these all were explained in the fifth point of interference of light waves and Young's experiment. Then in diffraction we understood the concept of diffraction, what is diffraction, why it is only observed when the obstacle is around, diffraction is nothing but bending of light when the obstacle is of the order of the wavelength of light. So why diffraction happens, why we cannot see a shadow on the portions if we understood every concept using Descartes theory of light, why was wave theory necessary for it. Then we also understood a single slit diffraction pattern, as in the path, as the path difference increases the intensity of the bright fringe keeps on decreasing. So this complete concept was being understood in diffraction. Then in second concept we understood that in diffraction interference of light is nothing but superposition of two different diffraction patterns. So this was another concept of diffraction. Finally after diffraction was being completed, we are now on the last point of wave optics, which is polarization. What is polarization? Polarization is nothing but the vibrations of the light are in the perpendicular directions of magnetic wave. Let us suppose we understand the light wave as a combination of electromagnetic waves. So if it is electrical wave plus magnetic waves which are perpendicular to each other and they are perpendicular to the direction of propagation of light, then if we understand that there is no magnetic effect and the light is being propagated only to electromagnetic waves, then we made some diagrams. Then if it is a combination of different waves inclined at some different angles, then a combination of that is called as an unpolarized light. If it is a polarized light, that means only the vibration is happening in single direction. So either it can be a y polarized wave, z polarized wave, depending on the direction of propagation. So these are concepts we understood in the previous lecture only. I may revise those again. So in the last lecture also we understood the concept of transverse wave, polarized wave, plane polarized wave, etc. So now let us move on with the further discussion of polarization. So please look over it carefully. So these were the concepts I explained to in the last lecture only. So this is just let me change the color so that I can tell you today's discussion. So this was the concept we understood in the last slide. What is unpolarized light? How do we make it into, change the components in only x and y direction, or let us suppose in y and z direction, and then we try to find out the denotion of unpolarized light. Similarly a polarized light was also shown to you. If it is a y polarized light, there will be only a single direction of arrows up and down. If let us suppose it is z direction wave, then it will be in x and y direction, let us say z plus z and minus z. Then this was a denotion. I explained to you that we are not assuming magnetic waves displacement, we are only assuming electrical wave displacement, and let us suppose that this is the propagation, this is the direction of propagation. Let me write it here. This is the direction of propagation. This is the direction of propagation. So, this was the final polarization concept. Now, let us move on. So, yes, so this was also in the previous discussion we understood that using one of the example we took for a string, if we are attaching the string, we are fixing the string and we are trying to move it above and below, then sinusoidal waves are being created. Those sinusoidal waves can be mathematically interpreted as y of, which is a function of x and t, is equal to a sin kx minus omega t, where a is amplitude, omega is the angular frequency and lambda is equal to 2 pi by k. So, basically k is something related to lambda value. So, these were all things which we understood in the previous lecture only. This is how I explained to you. So, this can be a example of a y polarized light. So, I will write it again. So, this is a y polarized wave. It is only and only called y polarized wave such that we are assuming the plane to be like this. So, let us suppose we are assuming that y is in this direction and z is in this direction, then and only we can understand that this is a type of bipolarized wave. Similarly, if we are assuming this as the system, then this will be an example of a z polarized wave. So, these all things were understood to you. Then we also studied a concept called as linear wave. So, just revising every concept again. So, here we understood first of all transverse wave. Transverse waves, they are called a transverse wave because the displacement is at right angle to the direction of propagation of wave. So, this was the first concept called as transverse wave. Let me just, so this was first concept, then second was a bipolarized wave. So, if the polarization is only in y direction, then it is called as a bipolarized wave. The next concept was regarding the plane polarized wave. So, further the string always remains confined to xy plane. First of all, since each point of the string moves on a straight line, the wave is also referred to as a linearly polarized wave. So, this was the concept I explained to you using these dots. So, as you can see, if these dots are viewed of, let us say, from above or below, then that can be called as a linearly polarized wave. So, that is why the name suggests that it is linearly polarized wave. The next was further the string always remains confined to the xy plane and therefore, it is also referred to as plane polarized wave. So, because for our case it is always and only either in this direction. So, therefore, it is a plane polarized wave. It is always in a plane, that is why it is called as a plane polarized wave. Next is similar manner if so as the equation for y of xt was similar like this, similarly the equation for z polarized wave will be something like this. The equation on the right hand side will be same, but only the function will differ, and please make sure, as you can see here, that it is always a function of x and t only, because x is the direction of propagation of wave. So, this was the final concept which we understood. Then so now next thing we understood in the previous lecture was about Malus law. That is, first of all, we understood that if we have a plane, let us suppose this is the direction of propagation of light, and let us suppose this is the Polaroid. What is a Polaroid? Polaroid basically absorbs the electrons which are not in their way. Let us suppose if we are having a unpolarized wave like this and it is only and only passing y polarized wave, that means this direction of electrons will get absorbed by the Polaroid. So, this was the basic concept of Polaroid. So, let us suppose this is the direction of propagation of light and we have a single Polaroid named as P1. If the intensity of light here is I, then the intensity of light here will be I naught by 2. Similarly, but for different case at this position here, let us suppose we are changing the case. Let us suppose the value is intensity is I naught here, that means the intensity will be 2 I naught here. Then the intensity of intensity after the light is being passed through Polaroid P2 will depend on the angle between P1 and P2. What is the axis the angles make between P1 and P2? So, that axis is nothing but I naught. So, the intensity will be I naught cos square theta, where theta is the angle between, if it is written here. So, if the pass axis of, please look over here. So, now let me change to my original color. So, if the pass axis of the P2 makes an angle theta with the pass axis of P1, then the value of intensity after moving through both the polarities will be nothing but I is equal to I naught cos square theta. So, this is nothing but known as Malus law. Okay, so this thing is also done. Let us, so this discussion, this example 5 was also been explained in the last lecture only. Let us move on to today's discussion. So, now we are on the verge of completing polarization also. So, today we will understand two different concepts of how the polarization is being achieved. What is polarization? Polarization is basically a procedure to convert an unpolarized light into polarized light. Just let me draw it by a diagram also. Let us suppose this is an unpolarized light, let me write it. So, let us suppose this is an unpolarized light. Let us suppose this is the device which is used to convert, through which this light passes. We get only displacements in one direction. Let us suppose the direction be above and below, or we are denoting it as bipolarized. So, this is nothing but a polarized light. This is nothing but called as polarized light. So, this complete procedure of conversion of unpolarized light into polarized light is called as polarization. So, the process is called as polarization. Let me write it here. Process is called as polarization, and the device which is used for polarization is called as a Polaroid. Okay, so as these things are being explained, so now let us move on to first method by which polarization can be achieved, and that is called as polarization by scattering. So, now please look over here carefully. First of all, let me explain to you what is happening here. So, as you can see, this is one of the bright source of light, example sun, we can take it as sun. So, after the light is being emitted from the sun, after it is being scattered, the polarization has happened, and due to which as you can see, as if I try to explain to you what is happening here, this is nothing but, so this is, let us suppose if I take the direction, let me first of all assume the coordinates here. So, I need some space, let me just erase this. So, let us suppose I am assuming the coordinates, this to be x direction, inside let us suppose I am writing like this, let us say this to be y direction, and let us suppose this to be z direction. So, here what does this direction shows is, if we are assuming this, let me draw a magnified image of this. So, there is an arrow in both direction, there is a dot between. So, this arrows just differ that it is a y polarized wave in that direction, but this dot refers to a polarization also happening in this z direction. So, it is a y plus z, so it is a plane polarized wave, it is not a linear wave, sorry, it is a linear wave, but it is not a single y polarized or z polarized wave, it is a plane polarized wave. Why it is a plane polarized wave? Because it is happening in complete yz plane, therefore, it is combination of y and z. So, this dot here just refers that it is a z, it is in both direction, it is a y polarized wave also, it is a z polarized wave also. So, if I let us say if I draw it somewhere here by a different color, then it is an example of this wave. So, this is the wave which is being drawn there, but if I let us suppose if my eye is being kept here and if I try to view this from this angle, then this wave can be noted as an arrow in this form and a dot in this form. So, this is nothing but a denotation being kept here. So, what it is trying to say is, after the incident sunlight is being scattered, after the scattering, as you can see, only dots are visible, only dots are visible. So, these dots just refers that the polarization is being done. Because the polarization is done by scattering, it is called as method by polarization by scattering. And what does polarization do? What does polarization do? It is a process to convert unpolarized light into polarized light. So, here by scattering, as you can see that these types of arrows are deleted. So, what happened is, because of scattering, these electrons get absorbed, and hence the scattering has, hence the polarization has occurred. So, only so now if we take this direction as z direction, then only z direction, z polarized wave remains. So, hence polarization is done. So, now let us so this explanation I have explained to you. Now, let us move on to everything which is written over left hand side. Okay. So, the light from a clear blue portion of the sky shows a rise and fall of intensity when viewed through a Polaroid which is rotated. So, it is just a theory given to you that the light from a clear blue portion of sky shows a rise and fall of intensity. So, there can be a rise also, there can be a fall also when viewed through a Polaroid which is rotated, because if we try to rotate it, the intensity may change, and because due to intensity being the angle being changing, sometimes the intensity can be 0 also, the intensity can be maximum also. This is nothing but sunlight which has changed its direction, having been scattered on encountering the molecules of the Earth's atmosphere. So, just due to scattering, the direction has been changed, and because direction has been changed, the angle has been changed, and because the angle has been changed, the intensity is being changed. So, this is nothing but sunlight which has changed its direction, having been scattered on encountering the molecules of the Earth's atmosphere. As the above figure shows, so as you can see here, as the above figure shows, the incident sunlight is unpolarized. So, because it is a plane polarized wave, it is unpolarized light. So, this thing as I have already explained to you. The dot stand for polarization perpendicular to the plane of the figure. So, this also I have explained. So, this dot stands for nothing but a polarization perpendicular to the plane of the figure. The double arrows show polarization in the plane of the figure. So, here double arrows has shown that the polarization is in the plane. So, this, let us suppose this is the plane we are considering. So, the polarization is in this plane also, and if I take this plane in z direction, then the polarization is happening in this plane also. Okay. So, the dots stand for polarization perpendicular to the plane of the figure. The double arrows show polarization in the plane of the figure. There is no phase relation between these two in unpolarized light. So, just the final conclusion of this statement was, after the incident light is being captured, it was viewed that it is a combination of both a y polarized wave also and a z polarized wave also, because assuming that we are taking this coordinates into picture or this coordinate system into picture. Okay. Let us move on to next point now. So, under the influence of the electric field of the incident wave, the electrons in the molecules acquire components of motion in both these directions, quite evident. So, because of the electric field being happening, so electric field does not happen or vary such that in the atmosphere it is only available in y direction or x direction, z direction. It is uniform in complete atmosphere. So, because of uniformity, there is a polarization or a light is unpolarized due to the intensity of electric field being uniform in all the directions. Due to that, unpolarized wave are being observed when the incident light or incident sunlight is being captured or incident light is being studied. So, that is only written here, that the under influence of electric field, because this is uniform throughout the atmosphere of the incident waves, the electrons in the molecules acquire components of motion in both these directions. Therefore, there is a y polarization also and there is a z polarization also. We have drawn an observer looking at 90 degrees to the direction of sun. So, let us suppose we are an observer. So, the observer is here. Let us suppose there is an eye being kept here. So, what is happening is we are assuming it, or we are observing the light at an angle of 90 degrees. So, if the observer is at, so this is very important, that the scattering or the light to be observed should be at an angle of 90 degrees. Let us suppose the direction of what we can say sunlight is in this direction, then the viewer should be in this direction, so that the 90 degree angle has been drawn and the scattering is being performed. Okay. So, we have drawn an observer looking at 90 degree to direction of the sun. Clearly, charges accelerating parallel to the double arrows do not radiate energy towards this observer, since their acceleration has no transverse component. So, quite evident, because the scattering has occurred and there is no passage of light, or there is no, as you can see, the Polaroid is in this direction. So, there is no passage of this movement being turning and going here, quite evident, because only and only this portion will happen, or this will only be observed as a Polaroid, which will only and only pass those plane of polarized light such that these dots are available. As the angle, or as if I can say, as the scattering has happened such that this can't be changed into this form, or else let us suppose for one instance that the polarization would have happened in this way. Then after scattering, there may be a chance that the Polaroid had this type of polarized light into its picture. But because, please look over here carefully, because the scattering has happened in this way and this is in the plane of polarization, it is in the plane of polarization, that is why when we try to view it from this direction, these molecules are not absorbed, and hence we get a polarization being happening. So, this is the concept, this is the initial concept of scattering being observed here, that the radiation scattered by the molecule is therefore represented by dots. It is polarized perpendicular to the plane of the figure. So, please look over carefully, it is polarized perpendicular to the plane of the figure. This explains the polarization of scattered light from the sky. Similarly, the scattering of light by molecules was intensively investigated by C.V. Raman. C.V. Raman was an Indian scientist and his collaborators in Kolkata in 1920s. Raman was awarded the Nobel Prize of Physics in 1930 for his work. So, he performed his work on scattering of light. He also performed his works on why the light of our water is blue when oceans or seas or salts. So, the complete analysis was being done, and this was one of the, what we can say, application, or one of the instances of his work. So, in today's lecture let me stop it here only. So, first of all we started with the revision of polarization, and after that we started with what is polarization by scattering. So, polarization is by scattering is nothing but only because of the incident sunlight being in a different direction than the observer, or let us suppose being in a direction such that it is 90 degree. Scattering is happening, and because that scattering leads to molecules being absorbed in some particular directions, therefore polarization has occurred. Polarization is nothing but absorption of molecules in all other directions except one. Hence polarization has occurred, and therefore we can get this type of polarization as you can see in this figure. So, this is one of the example of polarization by scattering. In the next lecture I may start with next concept, that is polarization by reflection. After this summary will be done, and hence that will be the end of your wave optics. So, let me end it here only. Thank you.